Welcome to Hartman Math. Today we're talking about piecewise functions. So we have f of x that's defined in two different ways. This way, under this condition, for any x that happens to be less than or equal to -1. It's defined this way for any x that happens to be greater than -1. Now, being that we're in a linear unit, we're going to keep these parts here linear, but we could have parts of our graph that would be curved. We're just not going to look at that today. So we're going to look at two techniques. Two examples, or do two different ways of doing it. Pick the way that you like best. So the first way is, hey, these are y equals mx plus b. They are lines. We're going to graph the whole line lightly, and then we're going to see which part of the line stays and which part we get rid of. So we're going to look at this as being y equals -2x minus 4. It has a y-intercept of -4. So we'll put that point on the graph. It's got a slope of -2, so we're going to go down to right 1. We've got that point. And we might want to have a few more points. If we kind of see this pattern going this way, we'll put a point, and a point, and a point, and so on. And now we're going to lightly use a ruler, graph this line. Use arrows, but what we're saying here is that this is true for any x that's less than or equal to -1. So that's called the boundary value. So I'm going to go to the graph, find the x coordinate of -1 on the line, and that's going to be right here, and it has the or equal to, so we're going to go solid point right there. So I'm going to make that really thick, and then less than is that way. So I want this side of the line. That's the good side. The other side I do not want. So we're just going to erase the part that doesn't fit this description. We'll get rid of that. And there we are. Now we need to graph the other part. Y equals x plus 2. It's got a y-intercept of 2. And a slope of, there's an invisible 1. So that's a 1x. So up 1, right 1. Let's do it a few more times. And we'll graph that line. And now, which part is the good part for that one? We want x is greater than -1, so we're going to go to -1. That's right here. It does not have an or equal to. So we'll put a nice, clear, open point there. Greater than means go to the right, so the right side is good. We'll keep that, put an arrow there. We'll get rid of the part to the left, which doesn't fit our condition. So here's our piecewise graph. Now we can do all the analysis that we've been practicing before, such as domain and range, increasing, decreasing, constant, positive, negative, all those kinds of things. So the domain, left and right. How far left does it go? It's going left forever, negative infinity. How far right does it go? It's going right forever. The only question is what's happening at -1. That's a little iffy. Should -1 be in our domain? Because of the closed point right there on -1, it is. So we do have everything between negative infinity and positive infinity. Now range is y values, low to high, nothing, nothing. Here's how low we go. Go to -2. There is a closed point there, so that's going to be a bracket, and it does go up forever. So our range would be bracket -2 comma positive infinity. All right, there again is our graph. Where are we increasing? Where does the graph start to go up? It starts going up at -1. We care about x coordinates only. These are domain intervals. Starts going up at -1, stops going up. There's an arrow going right forever. So it stops going up. Since it doesn't, we would say positive infinity. Where is it going down? Again, we look at this from left to right, coming down, down, down. So it starts going down at, well, that's pointing left forever, negative infinity. Stops going down when x is -1. Where is it constant? Where is it horizontal? Where is it flat? Nowhere. So we would say none. Where is it positive? So where do we start being above the x-axis? Well, we got a section of the graph over here that's above. It starts being above negative infinity. That's going left forever. It stops being above when we hit the x-axis here at negative 2. But there's another part. All of this is above. So starting here, ending there. Starting at negative 1, ending at positive infinity. Where are we below? Only this section right here, from there to there. Negative 2 to negative 1. All right, let's look at example number 2. We got 3 pieces to our piecewise function. This time we're just going to plug in points. That's going to be our technique, is to plug in points. And we're going to plug in values of x that fit our condition. So they have to be less than 0. But technically, I'm actually going to start with this border value, this boundary value, and plug that in first. So I'm going to plug in 0. 1/3 of 0, 1/3 times 0 is 0, plus 1 is 1. I got a point at 0, 1. It does not have the or equal to. So we're going open circle. Now I want to pick other values of x that are less than 0. Like I could do negative 1. But when I substitute in, one of the first things I'm going to do is I'm going to divide by 3. So I don't want to pick negative 1. It's not easy to divide that by 3. So I'm going to think negative 3. So trying negative 3. Negative 3 divided by 3 is negative 1. Times 1 is still negative 1. Plus 1 is 0. So I plugged in negative 3. I got 0. If it's not a boundary value, it's just a regular point. If I want to try one more, again something easily divisible by 3, I'm going to pick negative 6. Divided by 3 is negative 2. Times 1 is still negative 2. Plus 1 is negative 1. So I started here and I'm going that way. That's my piece for the piecewise. All right, middle section, f of x equals 1. I want to plug in 0. I want to plug in 2 in for x. The thing is, there is no x. So there's nowhere to plug this in. No matter what I put for, if I do f of 0, f of 2, I will always get 1. So I plug in 0, I get 1. And that would be right here. And that's a bar underneath, so that's a closed point. Well, I already have a point there. A closed point would essentially fill in an open point. So that's right there. If I go 1, that's my output every time. So 1, 1. Go to the boundary, 2, 1, open circle. All right, one more. Boundary value being 2. Substitute that in. 2 divided by 2 is 1. Times negative 3 is negative 3. Plus 6 is 3. So 2, 3. It's got the bar, so closed point there. Something else, again, when I substitute in, first thing I have to do is divide by 2. So I want to pick a number that's nice to divide by 2. So I'm going to pick 4. 4 divided by 2 is 2. Times negative 3 is negative 6. Plus 6 is 0. Point. And if I do one more 6, 6 divided by 2 is 3. Times negative 3 is negative 9. Add 6, we get negative 3. So I started here and I'm going this direction, so that's the way that we go on our graph. And there's the graph. Now how about domain? Goes forever left, goes forever right. The only issue we had is here at 2, but we do have a closed point. So it's everything from from negative infinity to positive infinity. The range, how low do we go? It goes down to negative infinity. How high does it go? 3. And it hits 3 with a close point. So that would be a bracket. If that was an open point up there, we would have a parenthesis. Where is it going up? Up, 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 up. This whole section is going up from negative infinity until we get to an x-coordinate of 0. Decreasing right here, starting at 2, ending at, doesn't end, keeps going down forever. That's going to the right forever. Again, we're talking about domain intervals, so x-coordinates is how we respond. And then where is it constant? It is flat from 0 to 2. And lastly, positive and negative. Where are we positive? Where are we above the x-axis? Starting here, starting at negative 3, all above, still above, until we get to 4. There's 2 different parts where we're below. This is below from negative infinity until we get to negative 3. And then starting here at 4, going right forever to positive infinity. That's another interval where we're negative. So those are the 2 ways. We had graph the whole line and then erase the bad part that doesn't fit the condition. There are conditions. Or plug in points that fit this description. You do have to plug in boundary values at all times and decide if there are open points or not. So I have one for you to try. Go ahead and pause the video here. As you get the graph, domain, range, increasing, decreasing, constant. Don't forget about positive, negative. Pause here, come up with it, hit play when you're ready. Again, there's that constant. Y is always equal to negative 1. So that's the horizontal part. Always got a value of negative 1 between here and here. And then y equals 3x minus 6. It would have had a y-intercept at negative 6 with a slope of 3. And this is the part that we keep. The good part, x greater than or equal to 1. So there we are. Domain starts at negative 4. Goes right forever. The range, the low point is negative 3. It's increasing all along here from 1 to infinity. It's never going down, so there's no decreasing section, but it is constant between negative 4 and 1. That's it for today. See you next time.